Hello guys, welcome to the next part of the CSS problem set. So today's problem is Tower of Hanoi. So it's quite a famous problem, and here we are given three rods and we have to move the discs from rod 1 to rod 3, and the rule is that in each move we can move only one rod and we cannot put any bigger rod on a small rod. So how to approach this problem? So this is a recursive problem, and the solution to this is like quite, you need to like think upon it for a while to understand the solution. Like first time when I saw the recursive solution, I was also not able to get it. So let me start with a single rod. So for example, if I have one rod and I want to move it from 1 to 3, so what is the best way? Like I can directly take it from here and put it in rod 3. So I have only one move from 1 to, I can put it from rod 1 to rod 3, and I have one move. Okay, let's go ahead. Now let's check for n is equals to 2. So there are three rods, 1, 2 and 3, and two discs are there. Now to move two discs from 1 to 3, so what I can do is, first I need to move rod 1, disc 1 to rod 2. So this problem is like similar to the earlier one which I solved. Now let me name this disk as A. So I need to move this disk A from rod 1 to rod 2. So this is a similar case for n is equals to 1, where I want to move this disk from rod 1 to rod 2. So here only my destination is changed and rest of the problem remained the same. So here we saw that for n is equal to 1, I can directly move. Similarly, here also I can directly move this disk A from rod 1 to rod 2. So I moved this disk from rod 1 to rod 2. Now again I am left with only one disk here, and we saw that for one disk I can directly move. So here is my disk B, and let me name it as B. Yeah, so I can like directly move the disk B from rod 1 to rod 3. And again now uh, I have to move this single disk from rod 2 to rod 3. So only source and destination are changed. Rest the problem is similar to the disk n is equals to 1. For example, in n is equals to 1, if I have to move from the disk from rod is 2 to rod 3, so I can directly move. So this is the way to solve for n is equals to 2. So as you can see here, while solving for n is equals to 2, we took the help of n is equals to 1 many times. So let's go on for a bigger test case, n is equals to 3. So now I have three disks, 1, 2 and 3. This is first rod, this is second rod, this is third rod. Let me name the disk. Smaller one is A, then B and then C. So this problem is also quite similar. So first I have to move these two disks A and B to rod 2. So now to move two disks from 1 to 2, uh, we have solved this similar problem for n is equals to 2. Like here, what we were doing was, we were taking these rods from rod 1 to rod 3, but here the change is that we have to take it from 1 to 2 rather than 3. So this is the same problem, and we follow the similar steps. First we take this disk and then this disk, so, and move them to rod 2. Now I am directly skipping the steps. So once these are moved to here, so I can move my disk C directly to rod 3. So what I am left with is with this structure. C disk is moved, and again two disks are left here, A and B. Now again, this is the problem which we solved earlier. Just source and destination rods are changed. Now from rod 2, I have to move two rods to 3, third rod. So here again we will follow the same steps as I showed in n is equals to 2. Only the source and destination are changed, and thus our final result will be like three rods would have been transferred here. Okay, so what we are doing is, for example, if I have, wait, sorry, if I have n disks here, let us say here I have n disks. So what I am doing is I am taking n minus 1 disks to this rod. Next step, only one big rod is remaining here, and rest n minus 1 rods are shifted to rod 2. Then in one step I take this big rod from rod 1 to rod 3. So I take this big rod from 1 to 3, and these n minus 1 rods stay here. And then in the final step, I just take these n minus 1 rods from 2 to 3. So this is how I am transferring the rods. Okay, so let me write the code for it. After then, we will understand the dry run for this code. So I have rod 1. So let's call the function f n, and from 1 to 3 I need to take n rods from rod number 1 to rod number 3. Int n comma int r1 comma int r3. Now what we saw was, if n is equals to 1, then I don't need to do anything. I can just directly see out r1, like we can take directly from rod 1 to rod 3 and just return. Now what were the steps? Like I am taking n minus 1 rods from rod 1 to rod 2. Now to find the rod 2, what we are doing here is, since all the rods are numbered from 1, 2 and 3, so total sum will be 6. So it becomes 6 minus r1 minus r3. So this gives me the rod 2. And now I am taking now one disk is left. So I will take that disk and move it to the destination rod. So I can directly call the function, or I can just print it. Doesn't matter actually. So I am taking now the single disk remaining from rod 1 to rod 3. And now in the remaining steps, what I will do is, now since the disks were in rod 2, so now from rod 2 to rod 3, I will shift them. So let me check whether I am getting correct output or not. Let us say currently I have 2 rods. Yeah, so for 2 rods, I am getting first move from rod 1 to 2, then 1 to 3, and then 2 to 3. Yeah, this is fine. Let's check for rod 3, and the total disks is 3. So yeah, this is also, I'm getting the correct answer. Now let me show the dry run for this recursion, or you can say the recurrence tree. Wait. Okay, so I hope the code is visible, and I have already drawn a tree here to like save the time. Okay, so this is the tree and here is the code. So we have called the function. Let me make it a little big. So we have called the function for, there are 3 rods and I want to move them from rod 1 to rod 3. So initial call will check whether n is 1 or not. Since n is not 1, so it will call this line will call, like we need to move 2 rods from rod 1 to rod 2. So in this diagram you check, we reach here, we need to move 2 rods from 1 to 2. And when we enter the function again, so it will check whether n is 1 or not. Since n is not 1, so again we will move, we will call this function. So it will again do n minus 1 comma r1 to 6 minus r1 comma r3. So when we just put in these values, so it will make this function. That means we are taking one disk from rod 1 to rod 3. And now since n is 1, so I will directly print r1 comma r3. That means one disk has been moved from rod 1 to rod 3. Then this function will turn back and the line of execution reach this function, which is simply print take one rod from r1 to r3. So that means out of these two disks, one disk has been taken, and now the remaining one disk has to be moved from rod 1 to rod 2. So 1 to 2 is printed. After that, again, we need to take back the rod 1, which we move from rod 1 to rod 3 back to 2. So this becomes this function. So from 3 to 2, we need to bring it back. So from 3 to 2. Now again, when these calls are over, so then we will take, that means these calls represent that two disks have been transferred to the adjacent rod. For example, from uh, rod 1 to 2, two disks has been transferred. Now what we will do is we will transfer the biggest disk from rod 1 to rod 3. So the next step is from rod 1 to rod 3. The biggest disk has been transferred and the two disks are lying here. Now our goal is to take these two disks from rod 2 to rod 3. So here is the function call. Take two disks from rod 2 to rod 3. Now the steps for these are: take a single disk from rod 2 to rod 1. So if I take single disk from rod 2 to rod 1, so after this rod 2 to rod 1, now this function return backs, and now I have to take the only disk left here. For example, now the current situation is something like this. So now I have to take this disk back to 3 or above the biggest disk. So this represents 2 comma 3. That means I have to take the disk present on second rod to rod 3. And now the remaining one disk, which is the smallest disk, is currently present in the first rod. Now I have to take it back to the third rod. Now I will take it back to the third rod. So this is how the recursion is working, and now all the disks are transferred. So what we are noticing here, that for n is equals to 1, I was having one step. For n is equals to 2, I was having 3 steps. For n is equals to 3, I am having 7 steps. So this is always 2 to the power n minus 1. So in the problem also, we need to print the number of steps. So here, like, I can directly output the number of steps as Cout 2 to the power n minus 1. And let's check. Yeah, so let me submit this solution. As you can see, it got accepted. So that's it for today's video, guys, and if you have any doubts regarding this problem, so you can ask me in the comment section. I will try to reply as soon as possible. Thank you.